Hello, I'm at TCT Show at Birmingham NEC, and that stands for Time Compression Technology, so it's all about rapid prototyping. There's a lot of 3D printing here. This year I'm exhibiting with Lulzbot, and I'm here with Josh and Ben from Lulzbot, who've come over from Colorado, and it's Lulzbot's first international show. So it's about 10 minutes to the doors, and we're all set up and almost ready to go. I've got one entire side of the stand here with my BB-8 and the video of it running at Star Wars Celebration, so I don't have to put it on the floor for every single person who wants to see it working. And I've also got my Gonk droid, which I might try and write some code for if there's time, although I'm expecting it to be very busy. We've got a Lulzbot Mini here with some 3D printed samples, and we also have the TAS-6 with a very special new type of extruder and hot end.
So this is the Lulzbot More extruder. It is in development. We'll be announcing a release date sometime in the near future. It has a 1.2 millimeter nozzle with a longer heater block, so we can push filament through it at an accelerated rate. And right now we're printing tea glass and printing a vase that looks like this. And this will take about 6 hours to print, and it's about a pound of tea glass film. I'm not sure exactly what our feed rate is right now, but we can print about 100 grams an hour with the More extruder, which means you could run through a 1 kilogram spool in about 10 hours. It's awesome for aesthetics, but it's also really great for making jigs quickly, making mechanical parts quickly, and it's got, the parts have a ton of strength compared to things printed with the standard extruder.
There was a rather interesting Polaroid 3D printer stand, but their filament is £50 in money for 750 grams, and it's chipped, so you can't use anyone else's. The MakerBot stand was there as usual. They had an HP logo on, which is rather interesting, and we think that's because of the HP Sprout, which isn't a 3D scanner. This is the Stratasys stand, which I like to film every year just to show you how big it is and how much money they've got. It's obviously very swish, and they had a kind of 3D printed, I guess, fighter jet on the corner, which was rather nice. The show seemed to be sponsored by multiple people. Autodesk had their name on the map, but again, Stratasys had their name up on all the posters, so I'm not quite sure who the official show sponsor was. By far the biggest stand this year was the HP stand with the tagline "Keep Reinventing," but perhaps if they should change it to "Keep Re-announcing." They're still promoting, of course, their colour jet technology or whatever it's called, but their stand was absolutely huge. They seemed to have meeting rooms built into it, and went on forever and ever, so I filmed it just to show how big it was, really. It goes all the way around here, and kind of keeps going, really. And I thought at one point I got to the end and it was someone else's stand, but actually no, it's still got HP written on it, so not sure how much it cost, but probably pocket money to them, I guess. This is still part of it. There were talks and things on the stage which I didn't have time to go to, unfortunately, but I did get to go to the after show party this year, which is coming up later in the video. It's early Saturday afternoon, it's really busy, and there's no more space in the stand because it's full of people looking at things. So this is clear Tallman tea glass, and it looks very, very clear. Not so much at this angle, but the extrusions are so fat, obviously the light goes through it a lot better, which is very nice. I'm here with 3D Filaprint, who I was exhibiting with last year. I'm here with Tim, the boss of 3D Filaprint. How's it going?
Yeah, it's a good show today. We've got there's a lot more materials this year for the engineering materials that there were last year. We did a project this year that included like the conductive filament that we had. We showed from Protopasta last year, but showing it this year, and it's working on a working pinball machine. But one of the main reasons why we then carried on with the pinball machine is because the conductive PLA played a big part. When we knew that would work, we then carried on with the rest of the actual pinball.
So this is a bumper?
Yes.
So what's, you've got some 7.4 series logic in there?
Yes, monostable.
Right. 2 solenoids?
2 solenoids.
Wow. How does it detect the ball?
2 conductive rings.
Right.
Which operate.
Yeah, wow. That's quite something.
I wanted to be able to show off UVs and PLAs. So we created what's known as, our designer there created this called a mutoscope, which, you know, it's an old 1930s design of what the original movies are used to look into one of these at the seaside and see the flickering movies. So we just created it so that we've got a UV light and an LED light inside. So whether you're using UV or whether you're using LED, you should be able to see it glow up. So all the barrels were of various materials, the brass, the bronze, the reflector lay by Kai Parthi, which is full of glass beads. So you can actually use this as a reflective material on workwear. And what we've actually done on the several t-shirts, we've made you can actually iron on reflector layer on the t-shirts.
How long did this take you?
1,200 hours of printing,
Right. How long to design?
200 on OpenSCAD,
Wow.
8.5 kilometres of filament,
Right.
not kilos, kilometres.
Yeah. Okay. This is amazing. And it's all Arduino driven?
Yes, 2 Arduinos, mainly for the number of IOs.
Yes. Is that Ninja Flex rubber belts?
Various, some are Ninja.
Right. Right, so about the Ninja Tech stands with Andrew.
Alright, we have just launched 2 new products called Cheetah and Armadillo. Cheetah is a flexible material, but it prints much faster than our standard Ninja Flex. Most flexibles on the market right now print around 30 millimeters a second. This will start at ABS settings and go up from there. So 60, 70 millimeters a second plus, but it still has some very good strength characteristics. It is a little bit stiffer. It's roughly a 95 short A, but you can see it's got some good flexibility to it. We also have a new material called Armadillo. It's a rigid polyurethane. Really good for abrasion resistance, interlayer adhesion. It's also very durable. So you can see here, it's very thin print. Has some flex to it, but does not snap like a PLA would when I bend it on itself. Just like the other polyurethanes, it's very good at bonding with other materials. Here's a dual print of PLA and Ninja Flex. You can see how well it bonds to the other material. Very strong. So this is essentially a bushing.
Are you shopping anywhere? Take the cover off your head. Why easy? Feel like a friend. Family can afford it. Why don't you come on?
Don't cross our back, 'cause you're gonna get stopped.
Let us keep moving. Keep that full stop moving. Like I got them moving. In my heart, it's gonna be alright. Another thing, hey, hey. Things gonna be, hey, hey, hey. Life is gonna shake, 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 shake. Shake it out, shake it out. Oh, how things gonna break, 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 break. Things gonna break, 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 break. Now it's gonna
guys.
We compete very, very much head-to-head.
Yeah, and then you've got ones like the ones that are supposed to do various different kind of.
Right, I'm on the E3D stand where the guys are going to tell me about their new filament called Scaffold.
Scaffold, water-soluble support. It's like PVA, but actually prints really nicely for a change. So demo object printed by Greg here. With support, without support. And we've got 3 running moving parts. This is the Knotted Orbit by Emmett Lalish. And I think that we printed this one specifically because Emmett Lalish said on his Thingiverse page, obviously impossible to print on an FFF type system. And he got it printed on a Z-Core powder printer. Challenge accepted, I suppose. Total geometric freedom, ability to print any shape, any geometry, moving parts, gearboxes we've done. What else have we done?
Gears, mechanical parts, bearing inserts.
Okay.
Just like
So is this what? It's completely water soluble, and how long does it take to dissolve? Something like that.
Well,
for
you take
instance?
most of it off by hand, so it's breakaway as well, and then what's left, a couple of hours, depending on how engrossed it is into the small parts or something like that.
Okay, and what sort of price is that per roll? Does it come on a kilogram roll or?
500 gram.
Okay.
I've no idea.
500 gram rolls.
Okay.
5 plus VAT.
Okay, so check out the E3D website.
Thank you.
All right. Cheers. Right, so this is a telescope mount.
Yeah, it's going to be a big telescope when it's built, fully 3D printed, apart from obviously the laser cut parts. It's going to be fully go-to, so we're putting gearboxes inside it with DC motors and control systems with the Raspberry Pi and Arduino.
Okay, and this is printed in E3D Edge.
E3D Edge, so it's very strong. It's printed with a volcano nozzle, so it's a 0.4 layer height, 0.6 nozzle. The biggest part we've done is about 300 by 200 by about 275, I think it is, on the height. We've also got big bits here. Wow. With big bearings inside.
Okay. Awesome. That looks pretty tough.
Yeah, very strong.
So you've got extremely good layer bonding, I guess.
Oh, extremely good layer bonding with the volcano because of the extra size of the film.
Yeah. And what sort of temperature does that print at?
It's about 240 on the nozzle and about 80 on the bed.
Yeah.
So it's very achievable.
It's nearly the end of the last day of the show, so we're about to pack up in about half an hour. So it's been a pretty good show. What do you think, guys?
Go ahead, Josh. It's been a great show. We've certainly enjoyed our time here in Birmingham. Big thanks to everybody at TCT for having us, and we can't wait to continue to talk with the people we've met here so far.
Cool, yeah, thanks everyone who stopped by the stand. See you next time.
Bye.